So first, defining this word regular. So we kind of went over it today in class too, but it's a fancy way of saying, or I say fancy, simple way of saying, all sides are congruent. All sides congruent. And it also says all the angles are congruent, but that doesn't come in to play so much in this lesson, but I'll go ahead and write it here. All angles congruent. So that word regular just means all sides are congruent and all angles are congruent. So for a regular triangle, we're really just talking about an equilateral triangle. So let's go ahead and draw an equilateral triangle to the best of our ability. I'm going to put tick marks on mine to remind myself that it's equilateral. And so, because it's equilateral, it's also equiangular. Of course, that's also the definition of a regular polygon. And so, the center, the radius, and the apothem are the same definitions for any number of sides. Okay? So the center is the intersection of all the bisectors of the angles, of the interior angles. So triangle has 3 interior angles. So if we bisect each of these angles, meaning cut them in half, we draw segments out from them, they intersect in one spot. We call that the center. Call it C for center. The radius is for any polygon, any regular polygon. It's from the vertex to the center. So I'll call that R. And the apothem is a perpendicular line from the center to the midpoint of the side. So perpendicular, and I'm going to call that A for apothem. So we notice we have this triangle here. Now this is equiangular, which means that all 3 angles are the same, and they also add up to 180. So that means each one of these angles must be, the whole thing must be 60 degrees. Now since we're bisecting the angle, this little angle right here must be half of that, which is 30. And if this is 30, and then we've got a right angle that's 90, then this other one must be 60. And so we have one of our special right triangles. So in a 30, 60, 90 triangle, 30, 60, 90, the shortest leg, we call X, the hypotenuse is twice as long as that, and then the long leg is X times the square root of 3. Similar to the 45, 45, 90, but then the hypotenuse is twice as long, and the other leg is times the square root of 3. So in this case, since we have A as the short leg, then the hypotenuse here is actually twice as long, 2A, and this leg is A times the square root of 3. So there's a relationship between the apothem and the radius, as well as the apothem and the side length. Because notice now the side length, right? The side length is actually 2A squared root of 3. Twice that long. Or you can also think of this leg right here as half of the side length. Okay, however you want to look at it. And so our area formula that we saw today as well also applies here. Half times the apothem times the perimeter. Okay, so given a picture like this and asked to find the area, let's start by writing down the formula. 1/2 lowercase a is apothem, capital P is perimeter. So area equals 1/2 apothem perimeter. Start by finding the center of the triangle, which you're kind of eyeballing it. You don't have to actually draw all the bisectors. And then draw your apothem. And then we can draw our triangle. Okay. Now again, anytime we have a triangle like this, these angles are always going to be the same. It's always a 30, 60, 90. So we don't have to like recalculate anything. It's always the same. Which means that this side will always be A squared root of 3, and the radius will always be 2A. Now we don't need to find the radius ever, unless you're asked, I suppose, for it, but we very rarely need to find the radius of the polygon, because all we need is the apothem and perimeter. So unless we're given the radius, we don't really need it. But we do need A. So since the whole side here is 24, this part right here, since it goes to the since the apothem connects the center to the midpoint, this part right here must be half of 24. So A squared root of 3 must equal 12 in this case. And so to figure out the apothem, we divide both sides by the square root of 3. And so we get A is 12 divided by the square root of 3, whatever number that is. We don't need to worry about that just yet. Okay, so we've got our apothem, 12 over the square root of 3. And to get our perimeter, since the triangle has 3 sides and they're all the same, we just multiply 3 times 24. And so 3 times 24 gives us 72. So continuing on, we have 1/2. We have our apothem, which is 12 divided by the square root of 3. And we have our perimeter, which is 72. And unlike today's where we were able to do all kinds of simplification, there's not a whole lot you can do with these because we don't very frequently get square root times square root. So the square roots very rarely will cancel out here. And so we pretty much just want to put this in the calculator. There's no very good. So we should get 249.415. Okay. Questions on that first one? Next. So we got a regular triangle, so let's start by, I suppose, drawing the triangle. We have an area formula, 1/2 apothem times perimeter. And this time we're actually given the perimeter. So the perimeter is 8 square roots of 3. Now, since we know the perimeter, if we want the side length, we divide the perimeter by the number of sides. To get the perimeter, we multiply side length by side. So to get the side length, we divide by 3 in this case. So each side is 8 square root of 3 divided by 3, which is some number. Okay. Now we've got our apothem. So there's our apothem. There's our triangle. And so a square root of 3 is equal to half of 8 square root of 3 over 3. Okay, so half of a square root of 3 over 3 would be 4 square root of 3 over 3. So 4 square root of 3 over 3. Now it's kind of useful to think, now again, you can divide by square root of 3 right here like that, but it's also useful to think of this in a slightly different way as 4/3 times the square root of 3. These things are equivalent. Because notice now we have a square root of 3 equals 4/3 square root of 3, so a must be 4/3. So sometimes it's handy to kind of think of things in a slightly different form so it's useful. And so now we can go back to our formula. 1/2 times 4/3 times 8 square roots of 3. And again, there's a little bit of simplification here, but nothing like what we did today. And so we can pretty much just put that in the calculator and see we get 9.23 feet. So in the first problem, we were given the side length, which we can use to find the apothem and the perimeter. And this one, we're given the perimeter, which we can use to find the side length, which then helps us find the apothem, right? So in general, the connection between all of these is going to be find the side length, and that'll lead you to the perimeter and the apothem. Okay. So next, a regular triangle. It says the apothem is 3. So this time we're actually given the apothem right off the bat. So lowercase a is 3. So area equals 1/2 apothem times perimeter. So again, we can follow the same process, but now we're given the apothem, which means we need to find the perimeter. So if this side is 3, this side must be 3 square root of 3 by our rule, a root 3, which means that the actual side length must be twice that, 6 square root of 3. And so our perimeter is 3 times that side length. So 3 times 6 square root of 3, which is 18 square root of 3. So once we have our apothem and our perimeter, we plug them back into our formula. So 1/2 times 3 times 18 square root of 3. Evaluate that in the calculator. And then we have units in this problem, feet. So we want to include units in our answer. if we remember, so we want feet squared. So we have 46.765 feet squared. So given side length, we find perimeter fairly easily, find the apothem using special right triangles. Given the perimeter, we find side length, then find the apothem. Given apothem, we find side length, and then perimeter. So it's, again, all kind of, side length is that middle connecting part between the apothem and the perimeter. Okay, next we're asked about, we're given a radius. So the radius is the connection from the vertex to the center. So if we draw our apothem here, so recall from our definition, we have A, then this hypotenuse is 2A. So if 2A is 10, A would need to be half of that, 5. So the apothem is 5. And then this other longer leg must be 5 square root of 3. Which means that our side length must be twice that, 10 square root of 3. And this makes up, each of these are 5 square roots of 3. So our perimeter would be 3 times 10 square root of 3, or 30 square root of 3. So area is 1/2 apothem times perimeter. 1/2 of 5 times 30 square root of 3. So 129.904, and again we have units, so I'll include them as an answer. Given radius, we find apothem, and side length, find perimeter. Okay. Last example. Two vertices of an equilateral triangle are 6, 10, and 1, -2. And the apothem has a length of 13 divided by 2 root 3. What is the area? Okay, so I'm going to draw our triangle again. We know our apothem. I'm just going to call it A because I don't want to write 13 over 2 root 3 too many times. So apothem, or area rather, equals 1/2 apothem times perimeter. I know our apothem is 13. And because of the parentheses here, we're dividing by 2 square root of 3, the whole thing. So it's not like 13 over 2 times square root of 3, it's 13 over 2 root 3. And so that means if we have, if this is A, then the side over here is A squared of 3, which would be 13 over 2 square roots of 3. Now we can't write this separately like I did on that previous example. Since square root of 3 is in the denominator, I can't like write this as 13 over 2 times square root of 3. Won't work. So we just kind of have to resort to dividing by square root of 3 here. I know it's looking really ugly, but it'll simplify here in a second. And so we have, whoa, 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 whoa. Back up. We know what, I'm sorry, I know what A is, right? I'm not solving for A. A is 13 times 2 root 3. So this is A squared root of 3, which means I can actually evaluate this. It's 13 over 2 square root of 3 times the square root of 3. Sorry about that. What I didn't look familiar. Okay. And so we can get the side length here. The square root of 3 is divide out, and we're left with this. This is 13 over 2. Okay. So if this is 13 over 2, then the side length is 2 times 13 over 2. So the side length must be 13. And so our perimeter would be 3 times 13, which is 39. Okay. But notice we're given some additional information. So this is one way we could do it, and it jives with everything else we've done. But let's do it a slightly different way using these 2 points that we were given. Let's just see what happens if we use those instead. And so we're given vertices, which would be our corners. And so if we use these vertices, we have 6, 10, and 1, -2. I'm not particularly concerned with it being accurate at all. But notice that the distance between these two should be 13, right? That's the side length. So I'm going to call that S for side length. And so if we find the distance, if we use a distance formula between these, we should get 13. So let's just confirm that's what happens. So distance formula, we have x2 minus x1 squared. So the difference in x's squared plus the difference in y's squared. So our difference in x's, we would have 1 minus 6. So 1 minus 6 squared plus -2 minus 10 squared. And so 1 minus 6 would give us -5. And so if we square that, we get 25. And -2 minus 10 gives us -12. If we square -12, we get 144. Remember, whatever you square a negative, you still get a positive, and multiply it by itself. And so we have the square root of 169, which is 13. So it checks out. It's the same. We get 13. So doing it either way works. Okay. If you're given the coordinates, I may ask you to say using these vertices. So I'd expect to use the distance formula, but you can definitely check it doing the same thing. And so we have our perimeter of 39. We have our apothem of 13 over 2 root 3. So we get 1/2 apothem, so 13 over 2 root 3 times 39. And one thing to note, whenever you put this in the calculator, be very careful that the 2 divided by 2 root 3 is actually in the denominator. So if you're using division, make sure you put the 2 root 3 in parentheses for itself. So you'd have like, if you write this out in the calculator, you should have something that would look like, second page here, so I can see. You would have something like 1 divided by 2, open parentheses, 13 divided by open parentheses, 2 squared of 3, close parentheses, and then you can put times 39. So if you're just typing the calculator straight, that's what it would look like. You can use control divide for this fraction as well, though. So you could do something like 1/2 and then parentheses, and then you can actually make it do 13 over 2 squared of 3 times 39. You can actually type that in the calculator using control divide. So whichever one you feel like. But just make sure that if you don't want to use control divide, you put this quantity in parentheses because it makes a difference. So divided by the whole thing. All right, so question on those 5 examples. Okay, so what question did you have a problem with? Number 2? Okay, so on number 2, let's see, we're given the side length. We know the side is 10. I'm labeling 10 on the outside. It's not really necessary at all. But okay, so let's see. I've got area equals 1/2 apothem times perimeter. Okay, so what's the perimeter? Okay, so 3 times 10 is 30. So that's the easy one to figure out here. So for the apothem, our triangle's kind of upside down, right? So it may help for you to actually turn your paper over if you're more comfortable. I'm just going to go like that. So there's my apothem. And then there's that. Which I know this side is 5. Right? But I also know that it's a root 3, which means that a root 3 must equal 5. It must be the same. And so we divide both sides by the square root of 3. And so a is equal to 5 over the square root of 3. So once I know my perimeter and my apothem, then we just come to our formula, 1/2 5 over root 3 times 30. And then it's just a matter of putting that in the calculator. Because there's, again, on this lesson, because you're not having multiple square roots, they don't cancel out. And so it's just not very much simplification possible. Is that, do you see though how we get that apothem if we know the side length? This part will always be half. And so a square root of 3 will always equal half of the second. And so then it's just going to be, basically you could take for granted that, let's say, we call the side, just for example, let's say I call the side like x, whatever x is. This will always be x divided by 2, right? And so the apothem will always be x divided by 2 divided by the square root of 3. Right? If that helps, that may confuse you even more, but that's the general idea. You can cut the side length in half and then divide that by square root of 3, and that'll give you the apothem. Okay? And you could do the reverse, right? So if you knew the apothem, right? If you, let's say we knew the apothem, then what we'd need to do, we would know the apothem was here. So that means that this is always at apothem times the square root of 3. So the side length is that times 2. Right? And so then, so we'd have the apothem times the square root of 3 times 2, and the perimeter would be 3 times that. So you could make the general argument that given the apothem, the perimeter would be 6, because that was, I mean, let's break it down. The perimeter would be 3, because there's 3 sides, times each side length, which was 2a squared of 3. And so you could make the argument that the perimeter will always be 6 times the apothem times the square root of 3. And that'll always give you a perimeter. That'd be a generalization. But memorizing all that stuff could get really, really crazy. And because we're not going to be doing just triangles, you don't want to try to memorize too much. You're better off memorizing the 30, 60, 90 because that shows up all over the place. I mean, it's not just geometry. You'll see it next year in Algebra 2 and in pre-cal and even in calculus music. So that fact itself is much more useful than some random memorization of how to find the perimeter. Okay? So. All right. Anything else? I'm going to stop the recording now.